of this strictly. I'll write it here. No. So dV equal to minus of ER E3 EP3. I'll write it, or E in. I'll write it. What is the electric field inside the uniformly charged sphere? Do we know that value? Yes, we have calculated. So which is equal to KQ small r by R cube. Now, what is the angle between E bar and DR bar? DR bar I'll measure radially outward, and how is E bar? E in, it is also radially outward. So angle between them is 180 degrees. So DR equal to cos 0 degrees. So this will become KQ by R cube, take it outside. So this will become R square DR, negative sign. This one. What should be the limit? Do we know potential at the center? Do we know potential at the center of the uniformly charged sphere? The answer is no. Do we know potential on the surface? Yes, we know potential on the surface. So therefore the limit at distance small r equal to capital R, potential on the surface Vs. Anywhere at a distance small r, I don't know that, that is V in. Limits, I don't know. Actually, it should have been 0 to small r. I agree. But do we know potential at the center? We don't know. We know on the surface. So what is the small r value on the surface will be capital R. So on the surface, what is the potential? It is Vs. Are you able to understand? 0 to small r, okay, I could have done, but I don't know potential at center. So therefore the limits capital R to small r I'm picking up. Okay, further solving this, V in minus Vs. So this will become V in minus Vs minus KQ by R cube, R square minus capital R square.
Sir, thereafter integration R cube by 3, no, sir?
R cube by 3 will come, huh? Yeah. Symbol, yeah. Okay, this 3, let me keep here. So further, let me substitute all these things. What is V in? What is Vs? Vs equal to KQ by R. KQ by R square, 3R square, plus KQ by 3R. Then this will be V in equal to KQ by R square, 3R square. This if I send on this side.
And minus.
This will be negative, no?
Sir, it is R cube by 3, sir, not R square by 3.
R cube, oh. Yeah, fine. R cube by 3. This is R square, no?
R square by 2 will come.
R dr, I don't know. Wait. Here it is. No. It will be R square by 2 will be there. Integral of R dr, how much you get? R square by 2. I think I'm correct. Okay, let me put all those things. K cube by 2R cube, R square minus R square. So this will become plus K cube by 2R. Yeah. K cube by R square. Okay, this will be 2R cube. Time being, let me write as it is. So this will become K cube by 2R plus K cube by R. This will become 3kq by 2r. So kq by r will become potential on the surface. If I take outside kq by r, so how much I'll get? 3 by 2 minus r square by 2r square. This will be a generalized formula you're supposed to remember. Very important. I think plenty of numericals are there if you know this. Otherwise, you have to derive so much. Potential anywhere inside the uniformly charged sphere is given by formula kq by r. And what is kqr? Kqr will become potential on the surface. I think somehow you have to manage here. Or if you want to, you can send on inside. But better to, there's a generalized formula I suggest you. Potential inside, here, let me write it. Potential on the surface. Potential inside the uniformly charged sphere. Now, can we calculate at center how much it will be? At center, R should be 0. Potential at center. If small r equals 0, then how much it is? (1.5) times that of surface. So where potential be more? At center, it will be more. V in or V naught symbol. Because in the diagram, I indicated VO there. So potential inside the center of solid sphere will be 1.5 times that of the surface. So this is strictly applicable for R less than capital R. Okay, nobody will ask you derivation, but the formula is very, very, very important. Potential inside uniformly charged sphere. Okay, what about the variation? Okay, already I have shown the electric field. The variation for the electric field will be this is for electric field. What about potential? Potential, it should be okay, here how much? Here it will be kq by r. Here it should be 1.5 times of kq by r. At center, it will be 1.5 kqr. On the surface, kq by r. Afterwards, it starts decreasing. If the negative charge sphere, the curve should be inverted. I think there's a least one. I can. Okay, the end formula. You do have many conservation of mechanical energy problems. All they revolve around this particular formula. I know in the advance